In this video, we are going to discuss a problem based on unit step function to find out the Laplace transform. Here, the function of t given as sine 2t from 0 to pi. The t interval is 0 to pi. When t greater than pi, the function of t is 0. Firstly, we have to write the given function in terms of unit step function. So let me express this as f of t equal to, see, sine 2t is f of first function of the t. That means we have the property that suppose the given function is discontinuous. Let me define it as f1 from 0 less than t less than a. When t is greater than a, the function is f2 of t. Then we have to express the function of t in terms of unit step function is f1 of t plus, we have to take the difference of f2 of t with the f1 of t, f2 of t minus f1 of t. With the unit step function, we have into u of t minus the intersecting point. It is discontinuous at a, so t minus a. In the present problem, our f1 of t is sine 2t and f2 of t, the function is defined as 0. So let me adopt to this property now. So we can write the given function as sine 2t plus 0 minus sine 2t into u of t minus, here a is pi. So now let me adopt the Laplace transform to this function, that is L of the function of t is equal to we have the Laplace transform of addition of two function is Laplace transform of the function of t plus Laplace transform of g of t. So this is called the linear property. So let me adopt the linear property to the given function, that is Laplace transform of sine 2t. So plus into minus is minus, Laplace transform of sine 2t into u of t minus pi. Let us find out the Laplace transform of sine 2t into u of t minus pi. Let me take the sine 2t as capital F of what we have, the unit step function, that is t minus pi, that will be the sine 2t So let me write capital F of t minus pi equal to sine 2t. We need to find out capital F of t. So therefore we have to replace t by t plus pi. Our intention is we need to find out capital F of t. If we replace t by t plus pi, see t we are replacing by t plus pi. We have minus pi here. So what we are getting as f of t, right? So in the right hand side, we have sine 2 of t plus pi. So let me write this as sine 2t plus 2 pi. See, sine of 360 plus theta. So sine of 360 plus theta is equal to what? Sine theta. So instead of theta, we have a 2t. That is sine 2t. So we have to find out the Laplace transform of capital F of t. So the Laplace transform of sine 2t we have to find out. So Laplace transform of sine 2t is 2 divided by s square plus 4. This is our f closure of s. Now we have to find out the Laplace transform of capital F of t minus pi into u of t minus pi. So we have the property of unit step function when the function in the format of capital F of t minus a into u of t minus a is e to the power of minus as. Here a is what? Pi. So pi into s, f closure of s. So here the f of t minus pi is sine 2t, sine 2t into u of t is equal to e to the power of minus pi into s. F closure of s is 2 divided by s square plus 4. Now let me substitute in the equation number 1. So Laplace transform of capital F of t we already determined it. So now let me substitute in equation number 1 directly. The Laplace transform of sine 2t is 2 divided by s square plus 2 square. 2 square is what? 4. Minus, we determined the Laplace transform of sine 2t into what? U of t minus pi. That is e to the power of minus pi into s into 2 divided by s square plus 4. In this, the common term of first and the second in the first and second term is 2 divided by s square plus 4 is 1 minus e to the power of minus pi into s. So in the first term, while we taken 2 by s square plus 1, what is the remaining is 1, right? So in the second term, we were having e to the power of what? Minus pi into s. So this is the Laplace transform of the given function.